Hello students, this is Miss Dalton. This is video 7.4 going over how to sketch polynomials. Okay, so I've written some steps here on how to draw your rough sketch. The first thing that you're going to do is you're going to plot the roots. And remember, your roots are your x-intercepts. Determine if the leading coefficient is positive or negative, because depending on what it is, that's going to tell you what's going to happen on the right side of your graph. Then determine if the degree is even or odd, which will help you determine what happens on the left side of the graph. Go ahead and use this chart to graph your end behavior. So remember, if your leading coefficient is positive, the right side will go up. And if your degree is even, the left side moves in the same direction, so it would also go up. If it is odd, it would move in the opposite direction, so your left side would go down. If your leading coefficient is negative, the right side goes down. And then if the degree is even, it would move in the same direction, so your left side would go down. Odd goes opposite direction, so your left side would go up. So use this chart to figure out what's happening on your left and right side. Then you're going to fill in the middle of the graph starting from the left arrow. Make sure to bounce at the double roots and wiggle at the triple roots. All right, so let's look at this first example. We have f of x equals negative x squared times x minus 4 quantity squared. So the first thing you're going to do is figure out what your roots are. So if I take x squared and set that equal to 0, that would be just 0, because you take the square root and it would be 0. So your root would be 0. Then over here, if you set this equal to 0, x minus 4 equals 0. If you solve for x, that would be equal to 4. So the first thing you're going to do is go ahead and plot those on your graph. So you're going to have an x-intercept at 0 and an x-intercept at 4. Okay, the leading coefficient is determined by taking the leading coefficients of each piece and multiplying them together. And remember, all we care about is whether it's positive or negative. So I would have the negative. Now notice that that negative is not being squared. It's the x that's being squared. So you would have a positive x that's being squared, and then you would have a positive x over here that's being squared as well. So this would be a negative leading coefficient. The degree, you're going to add those exponents. So 2 plus 2 is 4. So this is going to be an even degreed polynomial. And so you can figure out what the end behavior is going to be. Since the leading coefficient is negative, your right side goes down. And then since it's an even degreed polynomial, your left side's going to do the same thing. So it's going to go down as well. Now there is a bounce at 0 since x is squared. There's also going to be a bounce at 4 since that x minus 4 is squared. There's not going to be a wiggle, and there's not going to be a just cross. So now we're going to go ahead and graph it. Now when you graph it, you want to start on the right side of your graph and go ahead and do what the right side of the graph is supposed to do. This is supposed to bounce, but it also has to go down. So when I graph that, the right side is going down, but it's a bounce, so it's going to come off of it like that. Okay, then it's going to come up to 0, but it's also going to bounce at 0, and then notice that the left side is going to go down. So when I bring it back up to 0, it's going to bounce and then turn around and come down. So it looks like an upside, well, it looks like an M. All right, let's look at this next example. We have f of x equals x times x plus 2 quantity squared times x minus 1 to the third power. So our roots are if we set these equal to 0. So x equals 0 is just going to give you 0. X plus 2 equals 0. You'd have to subtract 2, so that would be a negative 2. And then x minus 1 equals 0, add 1, so that would be a positive 1. Your leading coefficient, I would have a positive times a positive squared times a positive cubed, and so that would be a positive leading coefficient. Your degree, you would have 1 plus 2 plus 3, so that would be 6, which would be an even degreed. So since your leading coefficient is positive, the right side's going to go up, and since it's an even degreed, the left side would go the same direction, so it'd be up. Okay, so we're going to have a bounce at negative 2. We're going to have a wiggle at 1 because it's to the third power, and then it's just going to cross at 0. So let's go ahead and graph those roots. We're going to have 1 at 0. We're going to have 1 at negative 2, and we're going to have 1 at 1. Okay, the right side is going to go up, and at 1, it's supposed to wiggle. So it's going to go up here, but then it's going to come down here like a wiggle. And then at 0, it's going to cross. So it's going to come around, turn, and then go through 0, just straight. And then it bounces at negative 2. So then it's going to come down, hit negative 2, and bounce off of it. And that's what your graph would look like. So you can see that the left side does in fact go up after it bounces at that negative 2. All right, here's our last example. We have f of x equals x plus 3 times x minus 1 times x plus 2 quantity cubed. So if we set those equal to 0, we've got x plus 3 equals 0, which would give me a root at negative 3. We have x minus 1 equals 0, so that would give you a root at positive 1. And x plus 2 equals 0 would give you a root at negative 2. The leading coefficient, since they're all positive, it would just remain positive. The degree would be 1 plus 1 plus 3, so that's 5, which would be an odd number. So our end behavior on the right side is going to go up since we have a positive leading coefficient, but because it's an odd degree, the left side is going to go in the opposite direction. It's going to go down. Bounce is anything that has a power of 2. We don't have anything that has a power of 2, so that has nothing there. Wiggle is going to be a power of 3, and so the root at negative 2 has a power of 3. And it's just going to cross at those others that have a power of 1. So negative 3 is going to be a cross, and positive 1 is going to be a cross. So go ahead and graph those intercepts. So we have negative 3, we have 1, and then we have negative 2. Okay, so start by graphing your right side. Your right side is going to go up, and at 1, it's just going to be a cross. So we're going to go up, just straight cross through it. Okay, at negative 2, we're going to have a wiggle. So we're going to come up to the negative 2, kind of on the side of it, and then we're going to wiggle our way through it. Sorry, let me redo that. It's going to wiggle through it. Okay, and then at negative 3, it's going to just cross. So we're going to come up, and then we're going to just go straight down through negative 3. And that would be a sketch. Again, the purpose of the sketch is not to make it look exactly like it, but just to get the overall shape. All right, so hopefully this is helpful. Please work through the rest of the practice problems and let me know if you have any questions.